To really understand the evolution of modern air combat, you have to look at the incredible and sometimes frustrating 50-year journey of the AIM-7 Sparrow missile. This isn't just a story about a weapon, but about the entire philosophy of how nations fight in the sky. It all began in the late 1940s with a program called Project Hotshot. The goal was ambitious: to shoot down enemy bombers before they could even see the intercepting aircraft. The very first versions, the AIM-7A and B, were fundamentally flawed because they were beam riders, meaning the missile had to stay inside a narrow radar cone projected by the plane. It was like trying to walk a tightrope while moving at supersonic speeds. If the pilot turned, the missile lost the beam and went dumb. The real story starts with the AIM-7C, also known as the Sparrow 3, which entered service in 1958. This was the moment Raytheon took over and changed the game by introducing semi-active radar homing. Instead of riding a beam, the missile had a seeker head that looked for radar energy bouncing off the target, acting like a moth flying toward a flashlight. The 7C was a technological marvel for its time, but it was built with vacuum tube technology. Imagine taking a fragile glass radio, strapping it to a rocket, and launching it off a carrier deck. The failure rate was incredibly high because the components simply couldn't handle the shock and vibration of combat flying. It was deployed on the F-3H Demon, a Navy fighter that was underpowered and struggled to even get the missile to the fight, but it proved the concept of beyond visual range warfare was possible. When the Vietnam War escalated, the Sparrow was strapped to the F-4 Phantom II. The Phantom was a beast of a plane, designed as a fleet defender with a massive radar and a distinct lack of an internal gun, because engineers arrogantly assumed missiles like the Sparrow would make dogfighting obsolete. They were wrong. The tropical heat and humidity of Southeast Asia wreaked havoc on the Sparrow's delicate electronics. The early models used in Vietnam had a dismal kill probability, often less than 10%. The motors would fail to ignite, or the guidance systems would drift. Furthermore, the rules of engagement required visual identification of targets, forcing Phantoms to close within visual range, effectively negating the Sparrow's long-range advantage and forcing it to be used in close quarters, where it was sluggish and hard to aim. This failure led to the development of the AIM-7F in the mid-1970s, which was the first truly reliable version of the missile. The engineers replaced the fragile vacuum tubes with solid-state microelectronics. This seems like a small detail, but it was revolutionary. It meant the missile could sit on a vibrating wingtip for hours, get slammed onto a carrier deck, and still work when the trigger was pulled. The 7F also introduced a dual-thrust rocket motor from Hercules. The first stage was a high-power boost to get the missile off the rail fast, and the second stage was a sustained burn that kept the missile cruising at high speed for nearly double the range of the older models. This was the weapon that armed the new generation of Teen series fighters, like the F-15 Eagle and the F-14 Tomcat. The F-15 was the perfect match for the Sparrow because its APG-63 radar was powerful enough to lock onto targets way further out than the missile could even fly, allowing the pilot to dictate the engagement. The F-14 used the Sparrow as a medium-range complement to its massive Phoenix missiles, giving it a layered defense. However, the 7F still had an analog seeker that could be fooled by ground clutter, radar waves bouncing off the Earth, and enemy jamming. This led to the creation of the AIM-7M in the early 1980s, the definitive version of the Sparrow. The 7M featured an inverse monopulse. Instead of scanning around looking for the strongest signal, the monopulse seeker stares at the target and compares the radar return across different quadrants of its antennas simultaneously. This made it incredibly accurate and gave it look-down, shoot-down capability. An F-15 could now fly high and shoot a Sparrow down at a MiG hugging the deck, and the missile wouldn't get confused by the ground. The 7M also had a much larger, continuous rod warhead. When it detonated, it expanded a ring of steel that acted like a giant saw, capable of slicing a fighter jet in half. This version proved its worth during Operation Desert Storm in 1991, where it was responsible for the vast majority of American air-to-air kills. Pilots finally had a weapon that worked as advertised, capable of ignoring Iraqi jamming attempts and hitting targets from over 20 miles away. Despite its success, the Sparrow family had one fatal flaw that eventually led to its retirement. It was semi-active. This meant the launching aircraft had to keep its radar pointed at the enemy from the moment of launch until the moment of impact. In a fight against multiple enemies, this was a death sentence. While guiding the missile, the pilot had to fly relatively straight and level, making themselves an easy target for return fire. If the pilot had to turn away to dodge a missile, the radar lock would break and the Sparrow would go stupid. This weakness drove the development of the AIM-120 AMRAAM, which has its own radar and is fire and forget. The aircraft that carried these missiles shaped history. The F-4 Phantom II was the rugged brawler that proved the concept but suffered from the technology's infancy. The F-15 Eagle refined the tactic, turning the Sparrow into a sniper's bullet thanks to superior avionics. The FA-18 Hornet used it to become a true multi-role fighter, able to defend the fleet and strike ground targets on the same mission. Even the F-16 Fighting Falcon, originally designed as a lightweight dogfighter with only heat-seeking sidewinders, was eventually upgraded to carry Sparrows to give it a beyond visual range punch. From the fragile vacuum tube-powered AIM-7C to the lethal digital precision of the AIM-7M, the Sparrow's history is the history of the Cold War itself, a constant race to shoot further, faster, and smarter, transforming air combat from a visual dogfight into a complex game of electronic chess played at 30,000 feet.